Well, we've been on this unit for day 11 now, which on a period system is the equivalent of 22 days. That's a lot on this unit. We got to get going. What we're still working on a little bit is empirical rule and using z-scores to find area under the curve. Someone wants me to go over.
Someone.
Yeah, just someone in general. Empirical rule.
I believe that's what they were requesting.
Okay. Yes, EMPIRICAL. Which one's question we're supposed to do? The very first one for the free response question. We're about to go over it. Part are we covering in today's DYU? That would be empirical rule and z-score stuff. What was the other one? And so we got some homework questions up on there as well. Was it 2.5?
Yes.
Okay. Did you check your answers already?
Yes, and I don't even know. Well, I didn't have answers, but I got the correct answer, so I don't even know how to do it. Like,
What?
whatever.
What?
Like, I don't even know how to set it up.
Let's see here.
Wait,
Let's see.
bro. I just want to spray my
Alright, it's 2.5. Okay, let's look right here.
Vote Kinsey here at vice president.
What number was it? 7 and 8? Okay. 7. Alright, so these are the multiple choice ones. So starting here, the weights of dimes are approximately normally distributed with a standard deviation of 0.02 grams. A dime that weighs 2.263 grams is at the 25th percentile. What is the mean? Okay, so first things first, what's like kind of the biggest detail we gotta pay attention to?
Normally distributed.
Normally distributed. So you know what I'm gonna do first?
Z-score.
Not a z-score. I'm gonna draw it. Please notice, I actually cannot do a z-score yet. Why not?
Because we don't have the standard deviation. We don't have the mean.
We don't have the mean, right? So I can't do a z-score. But I can draw a normal curve. And I'm going to kind of go ahead and estimate my standard deviations. Alright, what other information do they give us that might be kind of helpful here?
The 25th percentile.
25th percentile. We got to hold on to that. Because what is that 25th percentile in respect to that normal distribution? It's the what?
It has a z-score.
25% of the data.
Yes, so that is the what? It's not a z-score, it is an
Area.
area.
Oh.
We got to remember 25th percentile, that is the area at blank or what? Or below. Okay, so 25th percentile. Does anyone know approximately where that might be on this normal distribution if it's the 25th percentile? Not between -2 and -1. Say again. 0 and -1. So this is where the empirical rule is really useful and we want to pay attention to it. 68% of my data is right here, right? Okay, so then what is to the left of 1 below? Because isn't this 34% just on that 1/2?
Yeah.
Okay, so knowing that this to the left of 1 below is 16%, I know 25th percentile has to be somewhere in here. So this area is 0.25. Don't forget, what is the area under that curve? Always? 1 for 100%, okay? Yes, Ian?
Can you quickly explain like where 16 came from?
So remember, if I'm looking at 1 below to 1 above, by the empirical rule, that's 68% of the data.
Right.
So what's between 1 below and the mean?
34.
Right, what's 50 minus 34?
50.
Yep. Half my distribution is 50%. Minus that 34 is
Oh.
16. Now, what you could do is you could take that 34, add it to 50, and do 100 minus 84, but what do you still get? 16. So I just looked at the fact that I was only to the left half.
Okay.
Only cared about the left half.
Thank you.
And that got me to that 25th percentile. Okay, so 0.25 there. From this point, what can I do to get to my mean? this is like the one thing you've got to be able to remember. Because like I feel like up to this point, so I'm drawing it, I've got an area.
Oh, can't you manipulate the formula?
Not yet, because the formula you're referring to is this, right? Nope, just x minus mu divided by standard deviation. And I did that because technically it's talking about the population here. Do we know what z is?
Yeah.
No. Do we know what x is? Do I know what mu is?
No.
Do I know what sigma is?
Yes.
Notice, how many unknowns do I have?
2.
I have 2 unknowns, so I can't figure out yet, but the mu is what I'm trying to get to, so I need this z. How do I get that z? The calculator. Remember, what allows me to go from the area to a boundary? The inverse norm, right? So go to inverse normal. So we got to remember that's the small detail at this point. I got to use inverse normal on these calculators. Get the area. So if that's ever the case, turn it over. Grab a pencil. Hit the reset button. Hold that reset button down for a few seconds. Release it. Turn it off.
I think I can imagine touching this.
You really do. Okay, so please find my boundary. What is my z-score here?
Your z-score is.
Well, then put it in the calculator.
I forgot where we go.
Okay, so what's the button lets me do cool crap? Menu. Then probability or statistics. And then distributions. And then what's the area?
Inverse normal.
Inverse normal. And by the way, they're looking at the practice. Okay, you're just trying to use that as a reference. I got you. So the area would be 0.25, because remember the area always has to be at or below.
67.
So the z-score is 0.67?
Yeah.
That can't be 0.67.
It's
negative.
Star, you gotta verify.
I would say, why can't it be a 0.67? Because it has to be below the mean. Now solve your equation.
Wait, we're talking
Wait,
Don't forget, the calculator can solve the equation for you, do a numerical solve. But again, you can also multiply by 0.02,
negative 0.67.
right, because it's below the mean, right? And then solve from there, right? It's just algebraic manipulation at this point. But again, the calculator can solve an equation for you. Yeah, the area, remember, is at 0.25, right? Because it was that 25th percentile, so at 25% or below. Okay?
That's the area we're finding.
Yep.
Or the
We're
area that
doing
we're
mean or zero standard deviation of 1. Trying to get that z-score. Well, 2 things. One,
I got
actually do the inverse norm.
2.264.
The area is 0.25, right? Okay. And it has to be negative, Charlie, because remember, it's below the mean, isn't it? If it's 25th percentile, it's below the mean, so it has to be a negative number. A negative z-score. And oh, don't forget, that's the z-score, not the actual value. Right? It's like a penny can't have a negative weight.
Hashtag free.
So you get,
No, just do 0 and 1. That's the whole point. We're trying to get the z-score. Yep. There you go. Alright, solve the equation from there, but we gotta move on to the second question here, number 8 really quickly.
Is it C?
I have no idea off the top of my
Oh, I'm
head.
talking about 7.
Oh, I found it.
Sure, is number 7 C?
Yes.
Okay, I focus on the theory, not the actual final answer. But if that makes it work, that makes it work. Okay? Okay? Notice with number 8, it's a very similar idea. We have what percentile?
the
90th. Just, again, thinking through my empirical rule, where would the 90th percentile be?
Somewhere in the number 1.
What do you mean somewhere in the number 1?
Between number 1 and number 2.
Okay, so between 1 and 2. Remember, 95% is from 2 below to 2 above. So 90th percentile has to be here or below. Because remember, there's only going to be 2.5% in that tail past the 2. And that doesn't have, you don't have to have that perfect, the drawing, but it helps me visualize it. It should be something between 1 and 2. So how am I going to go from this area of 0.9?
An inverse.
Inverse norm again. So what's my z-score? So use your inverse norm, find the z-score for that one.
2.9.
Can't be 2.9.
I mean,
Cannot be 2.9. Why can't it be 2.9?
It's
Yeah.
below.
I would say, well, that, and we also just said it has to be between 1 and 2, doesn't it? 1 point what? 2.8? That makes sense.
What's the area?
what does sigma
Okay? So there's my z-score of 1.28. And then I just set that equation to mean of that. We're trying to find the value. Okay. So the value of that can minus 12.05 divided by a standard deviation of 0.02. And just solve that equation. I will point out there's only one equation that, or one expression that could work in this case for number 8. What is it?
9, because it's
Oh.
area.
Guys, just look at your answer choices. Don't always do all the work. Look at your answer choices. What's the only one that works?
E.
E. E is the only one that has a 1.28 for its z-score. So you don't always have to work it all the way through. Set things up, think through it critically. Okay? Inverse norm, right? Remember that area, that 90%, 90th percentile is an area of 0.9. Now, don't forget, okay, hey guys, don't forget this. If they had asked us to find the marker for the top 10%, the TI Inspire, can it do the top portion?
Yes.
No. Remember, Desmos can do either tail, and you can see it drawn out there. But remember, the TI Inspire can only do at or below. So if we wanted the top 10%, it would actually be exactly the same as this. Because you need the area at or below on the TI Inspire. So just keep that in mind. If you're ever given or asked about the top tail, the rightmost tail, you still need what's to the left on the TI Inspire. That was pretty good. All right.
So in inverse, so I just put area at 0.9, and is that enough, or should I just,
What?
sorry. Yeah, okay, never mind, I got it off, right?
Okay. You sure? Sorry, I was multitasking, trying to get this pulled up. You sure you got it, or do you need to ask a question?
You said it was equals or user
Yes.
to get the everything. Yep, got it.
Okay. All right, so I picked out a few questions based on errors I saw in the progress check. Remember, that's also why I want you to do progress checks. It's so that I can find issues and figure out how to address those before assessments. So don't forget, by the way, you can use your calculator to find these means. Have we talked about how to do a weighted mean calculator? Oh, no. Those are just, you don't need that. It's just 6 days and number of miles. We're good. Okay. First question is question 7. Okay, this is not on today's DYU, but this is something that will be on your test. So, following box plot summarizes the heights of a group of people who participate in a weekend biking. Okay, so we've got a box plot here. Which of the following statements is supported by the box plot? First things first, I know A can't be the answer. Why? Because it's not a mean. We got to recognize box plots. They don't have means, right? They have a median. So there's a median of 67. Number of people with a height at least 70 inches is greater than number of people with at most 62.
No.
So 70 is here. That's the what?
Q3.
Q3.
To the max.
And 62 or less. And so, I mean, that's a longer tail, right?
Yes,
So why is that one not true?
because it's still the same 25%.
It's still 25%, right? So don't forget that just means it's more densely packed there. Sometimes I just forget how much of a child star is. I shouldn't. I should remember, but okay. All right. So right here, guys. So we got to remember how to calculate outliers. Okay. It says based on 1.5 times the IQR rule, which of the following statements is a correct comparison of the distribution. So we should know outliers is kind of the idea right away. So what do I need first?
The Q1, Q3.
So the IQR, right? So 278 to 320, we can use calculators, but
63. No, it's not, it's 42.
42, yeah. So there's an IQR of 42 here, and then the IQR here is,
38, oh wait, no, 46.
yep, IQR of 46. And don't forget, when we say 1.5 times the IQR, that is beyond the quartiles, right? So on the upper end, so we would add this way, or on the lower end, we would subtract. So 1.5 times 42 would be 63. That's the 63 you're referring to. So anything beyond 383, do we have anything beyond that?
Yeah.
No.
No. Anything below 2, what do we say, 63, so 215
Yeah.
would be my fence. Do I have anything below 215? No. Okay. Looking at concrete, 1.5 times that would be 69. Does that sound right? So is there anything above that?
No.
No.
Yes.
If you take 69 and add that to 308, nothing is beyond that.
No.
But I take 69 and subtract, I get 193.
You do have an outlier.
So we have an outlier there. Notice, I don't know how many outliers I have there, but I do know I have a minimum that is below that fence. Okay? Please do remember also, I need y'all to remember this, if we are constructing a box plot, is my whisker going to go out to this 383?
No.
No. It goes to the last data point before that fence. Please keep that in mind. Last data point before that fence. Alright, let me see what 13 was. Yes, ma'am.
Last data, when you say last data for the fence, is the last value before the outliers?
It's the last data value before the outliers, yes. Which is also going to be before that fence. Okay, Dominican Republic. In August, the distribution of daily high temperatures is approximately normal with a mean of 86 degrees Fahrenheit, approximately 95%. I'm going to pause right there. What should you immediately think about when you see 95%?
Empirical rule.
We should think about that empirical rule. And I will point this out. You can try to do all this in your head, but if I see normal distribution, you know what I'm going to do? I'm going to draw it out. Okay? Drawing it out, taking that extra second helps. I know if it's saying 95%, I'm looking at how many standard deviations? 2. 95%, isn't that just 2 standard deviations?
Yes. Yes.
Oops, -1, -2. So, 95% of all daily high temperatures are between 83 and 89. So, notice you can fill this out with a little bit of information. So what does 1 standard deviation have to be?
60.
What?
You're talking about the 68%, got it.
1.5.
1.5, right? Notice, like drawing this out helps visualize it, so that you don't have to do it all in your head. What you could have done without drawing it out is said, you know what? 4 standard deviations, 6 degrees Fahrenheit over 4 standard deviations is 1.5 degrees per standard deviation, right? So, but notice how drawing it out helps me visualize it. I cannot emphasize enough that if you've got a normal distribution, draw that sucker out. Like, that is one of those cleanest ways to make sure that you can accurately see it. I always talk in my Algebra 2 classes about the 5 different mathematical representations: tables, graphs, algebra, words, and pictures, pictorial. And that's kind of like a graph, but it's also more pictorial. Pictures help us visualize things. They help us make it a little bit more concrete than the super abstract thing that it could have been. So draw it out, please. All right. All right, so 16, 17, 18. This is definitely where we missed the most questions. So we're going to take a little bit more time here. That's why I moved quicker through this. Hey guys, as soon as I read that first line, what am I going to do?
The distribution.
Draw it out.
I'm going to draw it out, right? Like, don't make your life hard. Draw that sucker out. Approximately normal. And what's going to be right in the center?
Let me.
470.
And I do want to point this out. personally, if I'm ever drawing this out, I'm going to put the actual value like this, but then I'm going to put a 0. What is that 0 representing?
0 is the z-scores.
That's my z-score, right? The standardized normal distribution is centered at 0 and has a standard deviation of 1. And it says the standard deviation is 64 transactions, but like, I don't want to take the time to do 478 plus 64. I could just do 1, and then 2, and 3. That's way easier than, I don't know, adding and subtracting 64. By the way, is that hard? No. Do I want to make my life harder than it has to be, though? No. You want to make your life harder than it has to be?
It's already hard,
So then don't add more difficulty to it, make it nice and easy. Alright, so which of the following is the proportion of daily transactions greater than 350? Notice, I made the z-distribution, z-scores, so I need to calculate a z-score. Value, 350, minus the mean of 478, divided by a standard deviation of 64.
Oh.
What's my z-score?
I got you.
I was like, please, someone calculate it. What, negative, oh, it's -2, right?
How'd you know that?
I realized that that's 128 there, 128 divided by 64. So, notice if I do this, okay, so guys, right here, I do want to point out, hey, shh, listen, I need us to recognize this. Could I use the calculator to calculate that percent or that proportion?
Yeah.
I could, right? Remember the whole thing is I've got a z-score now, but it's -2, it's an integer, so what can I use really quickly? The empirical rule, right? So like when I have an integer number of standard deviations, I'm looking out for that because it allows me to use the empirical rule. And so, remember, I like to play a game of halves, so I center around the mean. What's to the right of the mean? What percent? 50%? What's from 2 below to the mean?
34. 16.
47.5, or you could just say half of 95. Then add those together. Notice I'm not necessarily memorizing that 47.5. I'm just saying it's half of 95.
That's correct.
Because from 2 below to 2 above is 95% of my data. 68, 95, 99.7, play a game of halves. Half of the 2, and then half of the whole. So 97.5, is there a 0.975 or something close to it?
Yeah, it's 0.977.
Yep. And you know where that 0.977, ooh,
Wait, are you sure it's not D?
No, it's 0.97.
It's definitely E.
because this would be 47.5 plus 90. When I see two answers that close,
Oh wait, I'm stupid, it's 97.
yeah, 97.5, 0.977, yeah, not 0.95.
Alright, who said that?
Yeah, who said that? So again, how can I get more precise? Use the calculator to find the area. So, can you use the calculator? Yes. Why the stupid calculator? It makes your life easy.
For some reason, it makes my life harder.
It
Okay,
does.
hold on a second. Clearly, I have failed you AP statistics formula sheet. Hey guys, back in the day, and I know I sound old right away, but what I had to do was use this table. Now, we started to use calculators eventually, but notice this table is only giving me the area to the left of that z-score, so it never gave me what's to the right. So I had to then go to a -2. So my z-score, here's to the 10th place on the left, and then here's to the hundredths. So I need a -2.0, so notice that's a 0.0228. What's 1 minus 0.0228?
97.
Remember that 0.9778 that we saw earlier?
Man, how old?
1 minus that, I know. So, my point though is that calculator is a blessing. Okay? But draw it out. If you try to do this visually in your head without drawing it out, without drawing that normal distribution, yeah, your life is going to be hard. And I don't want your life to be hard. So look, we just go menu, statistics, distributions. Now you do have to remember, I have a boundary, so I do normal CDF. Okay, normal CDF. My lower bound, where did I stop shading on the left side?
2
negative 2.
or negative.
So 2 below. Be careful because it needs to be 2 below. Upper bound, does it technically ever stop going to the right?
No.
So I'm going to do, that number look familiar?
Actually, no.
It does. Drawing that normal distribution out can make your life easier. Please take advantage of that. All right, number 17. So the distribution of the amount of a customer's purchase at a convenience store is approximately normal. Draw it out. Mean of 1550, standard deviation of 1.72. Again, like, can I add and subtract 1.72 3 times above and 3 below? Sure, but man, I don't feel like doing all that. So I'm going to label this with my z-scores. If I can find my marker, it's way over there. So 1, 2, 3, 1, 2, and 3. And so what do I need to do with this right here? I need my z-scores. I need to know where those are located on my normal distribution. So 14 my value minus my mean of 1550 divided by 1.72. I need that z-score, so someone please calculate it.
I got you.
Thank you.
No, stop guys.
16 minus 1550 divided by 1.72.
It's negative 0.87209
Yeah. Second z-score? 290. Now notice I can just mark it on here and on here. And I need to find the area in between because it literally says between. So notice, there's my lower bound and there's my upper bound. So, Dixie, I don't know if this is the issue, but the calculator should make things easier if you draw it.
Yeah, I see.
Okay, were you drawing it out before?
No, it's not.
Okay, when you draw it out, the lower bound and the upper bound are wicked easy to see. Okay? Draw that normal distribution out. Get used to it. Okay?
How's it get marked?
It was a fantastic line. I'm so proud of you.
Thank you, Mr. Gideon.
I got you. 872. Not 32. And then 0.290.
It should be 1, but whatever.
I don't know what you're saying, but alright.
It runs up.
Somewhere around there. 0.422. 0.42. Answer choice is C. So again, drawing it out makes the calculator make sense. I will also point out on Desmos, remember how Desmos literally showed the area being shaded? That's really powerful. You just have to make sure you're clicking on the right stuff. All right, last one. So right away, I noticed this detail right here, and notice how they're trying to trick you. But what is the value that goes to the left of that equal sign? That's a z-score. Is that 28% a z-score?
No.
Guys, every AP exam does this. Every single one. You got to make sure you recognize that that 0.28 is not a z-score. The 0.28 is a what?
Value. No. It's not important.
I heard someone say it.
Area.
That's my area. 28% is the area. And so again, the more you play with it, the better you'll get. But I know right away my boundary line is here because 16% is in that left tail. So I need to find this boundary area, and I know my area, or the boundary, and I know my area is 0.28. So what do I need to do?
It's just 76 minus the mean of 103.
But I don't even have the z-score yet. I need my z-score. What do I need to do? Yeah, but how am I going to calculate it?
Probability,
Okay.
distribution,
Distributions.
inverse.
Inverse normal. Area of 0.28. There's my z-score. Equals, now I can use my value of, what was the value, 76? By the way, I will point this out. Did you know you didn't even have to use the calculator on this one?
No way.
I don't even remember what I used.
I want you to recognize, if you know that 28% is an area, not a z-score, answers A and B are out.
Right.
28th percentile, that z-score needs to be
58.
Negative?
negative. E is out. My value was 76, my mean was 103. Answer choice is D. So this though is how we streak. So one, guys, I want you to see both the statistical side of it. I have an area, I need to find the boundary. But I also want you to see the strategizing component of it, recognizing what's actually happening, knowing 28% is not a z-score, it's an area, knowing that 28th percentile pushes my z-score to be negative, and that my value is 76, I don't have to do any work in a calculator. Yes, Ian?
Okay, so anytime the percentile is less than 50, it's gonna be negative?
Right, because what does a z-score, a negative z-score indicate? That is below the,
Below the mean.
right, and isn't this right here my 50th percentile?
Yeah.
So anytime that percentile or the percent less is below 50, then I know it's a negative z-score. Yes, Raina?
Can we really quickly go over 13 again, because I didn't get what you explained about the change. I spent all the rest of it.
Well, I mean, you can do same thing that we talked about with, oh, I see. So look, if I see 95%, I'm thinking normal distribution.
Yeah.
But also you were looking heavily at the iPad instead of engaging. Make sure you engage as we're talking about it.
I
Look,
was engaging.
86 is my mean, right?
Yes.
If I've got 95%, I go 2 standard deviations above, which is 89. So we go with 2 standard deviations below and above.
How do you know the same?
It's 95%. I don't know what the standard deviation is yet. I know if I'm talking about 95% of the data, using the empirical rule of 68, 95, 99.7, that's 2 standard deviations above the mean. And so we just kind of said, okay, that's how we get to 89. That's it. Okay. Now you can, the thing I also pointed out is it's 4 standard deviations. So it was 6 degrees split over 4 standard deviations is 1.5 degrees as well. Same answer, right? Multiple ways to do it. Drawing it out helps. Okay, we got yeah, we already covered all of those ideas. All right, so it's time for DYU. It's only 1 page this time.
It's lunchtime.
It is not lunchtime. We got 12 minutes. I guess we could go over the AP free response question that I assigned.
Oh, assigned. Wait.
1, yes. I told you to do the first one about Robin's tips.
Mr. King, I was chasing the bag all weekend.
I'm trying to get you to chase the bag of, you know,
Oh.
I don't know, passing the AP exam. But also I'm pointing out, I'm not grading it. We're going over it. So, Robin's tips, what year was that from?
2016.
It was 2016.
Wait, what's the front? That's the only one.
Yeah, so the one on the front side. All right, Robin's tips. So write a few sentences to describe this distribution. So Robin works as a server in a small restaurant where she can earn a tip, extra money from each customer she serves. We got a histogram of her 60 tip amounts for 1 day of work. So when it says right here, write a few sentences to describe her distribution, what should we be thinking about?
Cuss.
Cuss? In context, okay. So remember, you can write it a million different ways. You just have to hit center, unusual aspects, shape, and spread. Okay, so I do prefer starting with center and with spread. So what could I say maybe about the center?
The data is centered around a median of 6.
Can't
Wait,
be
not
6.
6.
Think. Has to be between 2.5 and 5. How do we know that?
That's the lowest data is.
If it's 60 data points, it's 30 and 30, right?
Right.
Oh,
Isn't that gonna have to be right here?
Yep.
yes.
Now, do I know exactly where it is?
Nope.
No. So, I'm gonna start with context. So, Robin's tips in, was it a single day? In one day, or in that one day, is centered with a median between $2.50 and $5. And now, could I easily figure out IQR here?
Yeah, but.
I could figure out IQR. I'm probably just going to go range.
You can do that.
Yeah. As long as, and so I will say this, in the real world, if I have median, I prefer IQR. But with something like this, it's not super quick and easy. In the AP exam, as long as you have center and spread, you're good. So, and a range of what?
Of 22.5 at most.
22.4.
I will say this, you could say at most 22.5, but what's the minimum range then?
0.
Minimum range? That's the minimum value maybe.
The minimum range is
17.5. So notice the maximum goes from 0 to 22.5, but the minimum range would be from 2.5 up to 20. So it has a range between, normally you don't talk about a range between values, but because of this histogram you can and should, 17.5 or $17.50 and $22.50. You could probably get away with saying approximately. Has a range of approximately $20 if you check the rubric, right? That would probably be acceptable here. But notice center and spread. And yes, you could figure out IQR a little bit. From here, what else do we still need?
Shape.
I need shape, okay, so what should I say about shape?
Askew to the.
So the distribution is,
It's the range.
is there anything else about shape I could say?
It's unimodal.
Is unimodal
Roughly.
and skewed right with a, there we go, with a potential outlier and around $20 to $22.50. You can probably also talk about it as a gap, but I would wager it's probably an outlier with the median being all the way down between 250 and 5.
There's still a gap though, right?
So yeah, as I said, you could talk about a gap, or you could talk about a potential outlier. You can, but it's just unusual aspects, so you just have to hit one.
Oh. But like on exam, they
Again,
require,
spread, you only have to have one. Say again, Ian.
like AP, they require you to talk about the center and the spread.
Center, unusual aspects, shape, and spread.
I thought you said like, you have to talk about the center and spread.
Yeah.
Like as in you don't have to talk about the other two.
Nope. Cuss it in context. Gotta talk about all four. I start with center and spread usually. Okay. I can't really see it well, but I think what that says is one of the tips that was $8, if the tip had been $18, what would the increase of, what effect would the increase have had on the following statistics? So what would it do to the mean? It would increase the mean.
Because the mean is affected by,
Okay.
outliers.
Ooh, back up. Do we know it's an outlier?
Affected by increasing numbers.
Okay, so it is moved further to the right, causing the mean to move further to the right. Does anyone know, because I will say one of the ways you could justify it, you need to justify your answers. Does anyone know how we could have figured out how much it actually increases the mean by? I would not. Well, but also we don't know exactly these things.
By IQR?
No, because we're talking about mean again. Let me ask you this. How much did so how do we calculate mean?
By adding with that.
Adding and dividing by the sample size.
Right? Sum of x divided by the sample size. How much did my sum just increase by?
20.
Or
8 to 18 is increasing by 10. Split over how many data points?
60.
So it would have increased by 0.16, 16 cents. Or 0.16 repeating. 1/6. I've just done a lot with 6. So
That's how much the mean would increase by?
yeah, that's one of those I just know. Yeah, 16 cents
Oh, wow.
is how much the mean would increase by. The other way I know it is, the reason I know that is 1/3 is 0.3 repeating, and then 1/6 is dividing that in half. So 16 cents. Okay, but also I've been doing math at this level for a few years now. Yeah, and tutoring math way before that. All right, what about the median?
It would stay the same.
Why would it stay the same? Because the median would definitely actually stay the same.
Because the mean is resistant to.
So that was considered, I believe, a weak justification in this case. You're close, it being resistant. So the median, is it resistant to skewness and outliers? Sure, but there's another reason why the median wouldn't change at all. Because the median could have changed a little bit, but it won't change at all here. Why not?
Stay on the same side, repeat, doing the same solving.
I would say, isn't that already to the right of the median? And if I just go further to the right of the median, is the median going to shift at all? No. If it was below the median originally and then moved across, the median might change a little bit. But because it was already to the right, it wouldn't change. So let's see what the AP rubric has. Yes, ma'am?
How did you get the range?
So remember, range is maximum minus minimum, right? Hold on 1 second. 2016 AP statistics, free response question. All right, was that number 1?
Yes.
Okay. So the range you're asking about, maximum minus minimum. So the absolute maximum value is 22.5. The absolute minimum is 0.
Yeah.
So it's a maximum range of 22.5. But it could have been that this data point was actually 20 and this was 2.5. So 20 minus 2.5 would be 17.5. So the range is anywhere between, that should say 1750, not.
Okay.
It does say 1750, it got mixed into the dollar symbol, and 2250.
That makes sense.
Yep. So notice, okay, hold on 1 second. We had to hit these 5 things. Shape, skewed right, outlier, at least one, or gap. Notice you just had to hit one of those. Center between $2.50 and $5. I don't know how you get 262 and 513. Variability by spread. You could actually, I hate that they allowed this. They don't always anymore. Just oh yeah, so you can talk about either of those ways, but range would be the best. And then context, tip of bounce. Down here, you have to talk about the mean will increase and correctly justify why it will increase. Why the median will not change, or that it will not change and why. So they gave notes somewhere, but notice right here, that's the justification that they provided in their ideal response. Someone's asking a question. Yes, Phoebe?
It had like the sum.
Yes.
But then you had like anybody.
Yeah, so I guess I should clarify that. Yeah, you go ahead and head to lunch though, but it would have been, it's the sum of x, right? But that sum of x just had 10 cents added to it. Oh shoot, or $10 added to it. So you still have the sum of x divided by n, the original mean, plus 10 divided by n. So that's how much it really was. $10 over 60. So think about it this way. Let's say it is now the sum of y distribution. This sum of y is the sum of the original x values plus $10. You added $10 overall. Does that make sense? Okay. Yeah. 1 second. Let me stop the camera.
No.
That's why I said pens or pencils off. Just a pen, update what you need to. How did the yellow write? Fine? Okay. Alright. You want color instead of black. There you go. Alright. So, issues number one, I just did quick notes here. Empirical rule. What's the issue with this?
That's not
So
true.
it
Can't
can be
have
one,
like a-
two, or three.
Can't have a decimal. It has to be a integer, right? -3, -2, -1, 1, 0, 1, 2, 3. It has to be an integer between -3 and 3, right? So those are details that we want to remember, learn from, do better next time. Yes,
If
start.
I said a whole number,
I will allow it, but it's not a whole number because whole numbers are only 0, 1, 2, 3, etc., right? I'll allow it, but yeah, integers. Number two, empirical rule and z-scores can be used with skewed left distributions.
No, only normal.
Only normal distributions. I will point this out, I need you to be careful. Can you use z-scores with a skewed left distribution? Yes, just not to calculate area. Remember, a z-score in and of itself just is a placement, right? Where is that data value in respect to the mean and numbers of standard deviation? You just can't calculate area if it's skewed left. Okay, so you can always calculate a z-score, just cannot calculate area. Number three, remember 5% is outside of the two standard deviations, right? So 95% from 2 below to 2 above. So outside of that 95% is 5%, but what is less than 2 standard deviations below? 2.5%. You know what you could have done if you were struggling to figure this one out?
drawn it out.
Drawn it out. Right? Remember, 2 below to 2 above is 95%. So down here, it's 2.5%, 2.5%. Draw a visual to help you see that. Yes, Phoebe?
I just added and without you partially.
I would accept that. That you're recognizing the issue with that statement. That's perfectly acceptable. Yes, Raina?
I don't know what I did, but I fixed this 2 standard deviation, I just said 1 standard deviation.
But remember, 1 standard deviation is only 16%, right? So it couldn't be. I mean, like if you did 16% and 1 standard deviation, I would accept that. But what I really want us to recognize is that 5% was inside and 2.5% on either tail. Yes, Charlie.
I get confused when these kind of problems say less than 2 standard deviations below because that implies it's within that range instead of.
But if it's less than 2 standard deviations below, that is a z of -2 and below it. Does that make sense? That
It makes sense
Yeah.
the way I've been interpreting it, though, with like it's less than.
well, I'm glad, and here's the thing, and I'm glad you bring this up, and this is why I let tests replace DYU scores, right? Because that's something you want to learn from, because that's how the AP exam is going to word it, okay? So pay attention if it says above or below the mean, because if it's below, it's that -2, and less than, so it's below it. Yes, Ryan?
So the right answer is 2.5%.
It is 2.5%, right? We can see that using our empirical rule, okay? Number 4, the distribution is not symmetric. Just knowing it's the 3rd quartile doesn't give me a ton of information, right? Remember, a 3rd quartile tells me it's in the 75th percentile, which is an area. Whoops, not 20, 75th percentile. But that's an area, and I don't know a whole lot when it comes to area unless it's approximately normal, right? It's got to be approximately normal to connect area and z-scores. That's the big issue there. So keep that in mind, that unless it is approximately normal, I cannot connect z-scores and area. Got to have those two details connected. So again, by the way, don't forget, don't just mark it wrong, update your knowledge, update your information. I will wait until I see everyone finished adding notes. The big idea is I cannot connect z-scores and area unless it's approximately normal. Cannot connect z-scores and area unless it's approximately normal. And even if you got it right, and you want to write that note down, that's a good thing to be thinking about. Okay. Number 5, it is A. You had two approaches you could use with number 5. What are they? Well, I would always draw it out, right? So let me rephrase that. Once you draw it out, it's a normal distribution.
Can you convert them into z-scores?
So I could convert into z-scores or use empirical rule. Isn't one standard deviation above the mean the 125? And 2 standard deviations above the mean, right, is the 140? So all I wanted was this. So you could have easily just used z-scores there to find that area from 1 to 2. Or, how much is between 0 and 2? Remember this, half of that 95, right? 47.5. How much is in this area that I don't want? 34, half of that 68. 13.5%. So A, notice that's a percent to a proportion. Notice anytime I'm seeing an integer number of standard deviations, I can use the empirical rule. Okay? And it gets close enough. Again, you could use the calculator to find that 1 to 2. Yes, Mr. Kenny? Yep, 100%. So lots and lots of ways to approach this. Don't forget your z-scores. Don't forget to shade that area. Like, if you had just done a lower bound of 1, upper bound of 2 with your z-score, you would have gotten the same answer. But empirical rule is a quicker way. Okay? So this is very similar to that one question we looked at on the progress check. Lots of different ways to approach it. Okay? But if we're seeing 99.7, what number of standard deviation should we be thinking about? So 3, but 3 in either direction, right? So how many total standard deviations is that? 6. So you take your 24 inches here, you split it over 6 regions, you're left with 4 inches per standard deviation, right? So that 24 inches for 6 standard deviations gives me 4 inches per standard deviation.
How is that 24 inches?
Going from 5 feet to 7 feet, each foot is 12 inches. So 5 feet to 6 feet would have been 12 inches. 6 feet to 7 feet would be another 12 inches. What were you thinking?
I wasn't sure of inches, like measuring foot and stuff, so.
Yeah, if that measurements like that ever come up because of that difference in American Scientific Units, let me know and I can just point that out to you. But yeah, does that make sense now? Like a foot is 12 inches. I'm not saying does the measurement system make sense, because the measurement system doesn't make sense, but knowing that a foot is 12 inches, 5 to 6 feet is 12 inches, 6 to 7 feet is 12 inches. And just 12 plus 12 is. What? What'd you say?
I did that.
Oh my gosh. Even Star didn't think that.
I was locked in.
Yeah, right? Star has been locked in. Ever since that first test, y'all, Star's been locked in.
Hey, good job, Star.
Star's like, hold on.
Not locked in.
Alright, questions about that? Were we able to update our knowledge? Again, focusing on updating our knowledge. Number 7. Okay. So I hear some hows.
I thought it was easy.
Wait,
Yeah, that was
it should have been. Yeah, that's not right.
It's E, right?
Let's go.
Yes.
Thank you.
Yeah.
Wait, how is it E? Because you just put in your
I must have added a subtraction or something wrong. So, oh no, wait.
But that's not, it's not E.
It's not E.
It's not E.
Notice this is not the mean, that's X. And so if I want to be in the top 15%, okay, and I'm going to the calculator, top 15% is somewhere right here, I think. So this would be the top 15% in this region. So what area should we put in the calculator?
.5.
0.85 is the area. So be careful about that. That might have been what got some of us. But, so when you do inverse normal with that, what z-score did we get? Like a 1 point something? 1.06? 36? Oh, that's further than I would have thought. That sounds right, actually, from the calculations I did. That might be right. One point, that's a different one. Yeah, 1.36 sounds right. Oh, 1.036. 1.036 makes more sense. Okay. Because it is just over 1 standard deviation. Remember, that's equal to my value, which is 45, minus my mean. Nope, that's not a symbol for mean. Divided by my standard deviation of 4.9. Just thinking logistically about it, that means this has to be about 1 standard deviation above my mean, right? So then that would be about 1 standard deviation from there.
I didn't know that.
Huh?
I just subtracted 4.9.
From 45?
Yeah.
So you got lucky?
I guesstimate.
Notice, so like fine, but like you had to know you're at the 1 standard deviation
Yeah, I
mark.
did.
Okay, so you knew it was about that. Yeah. So notice you didn't solve that equation, guys. You did not have the mean, you were looking for the mean. Yes?
I don't get why we put .15 there and how we got the 85.
Well, remember it's in the top 15%, right? So the top 15% is there. So in the calculator you had to put 0.85 because the calculator can only do what's below.
Oh.
Does that make sense?
And so when we do the inverse normal, that gives you the z-score?
Mm-hmm.
Oh, because I was getting like 45. Because I did the .15.
Gotcha.
So I thought it would be
I need to look at your work because it's still showing them 45. I don't know.
I didn't do it.
But inverse norm with an area of 0.85, right? And so that gives you a z-score of 1.036. Set up your formula.
So the value of 1.036 is that when you put 0.85 in the calculator? Right?
The inverse norm with that area of 0.85, yes. So don't forget, if we're going from area to a boundary, we have to do an inverse norm. Okay? All right. D for number 8. I will point out, okay, we should recognize right away with Aaliyah, if she's 1 standard deviation above the mean, what percentile would she have to be?
I just read the answers, I didn't know that.
So guys, if we're looking at Aaliyah, she's almost 1 standard deviation above the mean, right? Okay, so you could do a normal distribution and let that be the upper bound, but wouldn't she have to be about the 83rd percentile?
Yeah.
Right, that's almost 1 standard deviation above.
I started with the wrong one.
So 1 standard deviation above would be 84th percentile, 34 plus 50. Okay, so 83rd right there.
I started the wrong one.
And notice, if she's at 83rd percentile, she's shorter than Jane. Okay?
Just the wrong one.
I marked
So
that
close.
one out. That was like the first
That was the first one I got.
All right, number 9. So I will point out, so 3rd quartile, immediately what percentile is that?
The 75th.
75th percentile, which is greater than the 70th. And then we actually just talked about if it's a z-score of 1,
Oh.
it's about the 84th percentile, right? Because there's 34% here and 50% there.
Wait, no, I don't do that. Because
If it's 1 standard deviation, a z-score of 1, that's 1 standard deviation above the mean, right? So what percentile is it? Well, there's 34% here, 50% there, 84th percentile. So I found those percentiles. There's other ways you could do it. You could convert that 70th percentile to a z-score, 75th percentile to a z-score. It's not necessarily what I would do. All right, We have down to 45 seconds. One, make sure your name's on the paper. Put all of yours together. Can someone get out their AP free response questions quickly so I can see which ones I want to assign? We're going to go over it tomorrow, but just go ahead and put them all together. I'll collect it. Okay.
I think I know.
We'll go over it tomorrow. All right.
Yeah, all right.
Lola, be patient.
Hey guys, let's see. The 2021 question and then the 2017 question. Do those tonight. 2021 and 2017 questions. Do those tonight. We'll go over them tomorrow. And then we'll stop this unit. Oh, I need your DYU star. Thank you. Thank you.
Oh, you didn't want to?
No, I didn't. I'd rather not.
Alright, so which free response questions are you doing tonight? 2017, 2021.
2021, I'm in the mini.
Okay.
Oh, that's so annoying.